Hello everyone, me, your friend Krishna Kumar Chaudhary, today came with content that is indeterminate form. Determinant form. Now, let's have this first definition of this indeterminate form. The limit of a function of the form which type of form? Limit x tends to a fx by gx. No, fx by gx. If any of the limit is in this type, means numerator and denominator should be there. Okay, and when condition is when both numerator and denominator approaches to 0 no, as x tends to a, no, or x approaches to a, x tends to a, then the limit takes the form. At that time the limit takes the form, which type of form? 0 by 0 form. No, because numerator and denominator both approaches to 0, then you will get the 0 by 0 form, which is meaningless. No, you cannot calculate it in your calculator. Meaningless. And expression where you got the meaningless expression is called indeterminate form. This is the definition of indeterminate form. For the what is the criteria for the indeterminate form? That should have approaches to 0 when you will substitute this x, no, at that point, no. And other indeterminate form are other indeterminate form are, that is infinity by infinity, or infinity minus infinity, or 0 to the power 0, or 1 plus to the power plus minus infinity, or infinity to the power 0, or 0 into infinity, etc. are the other indeterminate forms. So after getting the indeterminate form, which is meaningless, which you cannot calculate, then what is the rule? How will you calculate this indeterminate form limit? No, it is just a calculation of limit. How will you calculate? So a rule for calculating limits of fraction means fx and gx, no, fractions whose numerator and denominator approaches to 0 this rule is known as L'Hospital rule. No, L'Hospital rule. So if you will get indeterminate form by the help of L'Hospital rule, you can calculate the indeterminate form limit. Okay, what is then L'Hospital rule? What is the statement it says? How will you calculate it? So L'Hospital rule statements. Let's talk about the L'Hospital rule statement and its proof. So L'Hospital rule. Let us write here statement. L'Hospital rule. what is the statement of this. So for that, obviously where you will apply the L'Hospital rule, when there will be the meaningless indeterminate form. What is the indeterminate form? They are 0 by 0 form, and 0 by 0 means obviously there should have the two functions, no? So let two functions consider. Let fx and gx are two functions such that obviously the numerator and denominator both should approaches to 0, such that fa is equal to ga, both should be the 0, no? And another condition is both should have different derivative at that point, otherwise you cannot calculate it. So and their derivatives, and also their derivatives f dash x and g dash x are continuous at x equal to a, and obviously one of the condition is the denominator should not be equal to the derivative at that point, should not be equal to 0. Then it says that how will you calculate it? Limit x tends to a fx gx. Your calculation should be of this one, that e will be equal to their derivatives at that point. Limit x tends to a f dash x by g dash x, and if you will substitute the a, what you will get? F dash a by g dash a. This is your L'Hospital rule. Means if you at that point, now if you will do the derivative, then there will be no change in the functional values. So proof of this. So proof for the proof, I will start from here, from the MS middle side. So here limit x tends to a, that you have f dash x by g dash x, no, which is equal to limit x you can say, if you will substitute this, what you will get? F dash a upon g dash a. No, this is the derivative at a point. No, how will you and derivative in terms of limit? You can define limit x tends to a fx minus fa upon x minus a, and by derivative at a point, obviously how will you define? In similar technique in the limit form, limit x tends to a gx minus ga upon x minus a. So in aggregate you can write it, limit x tends to a x minus a, and x minus a can be cancelled, so remaining will be the fx minus fa upon gx minus ga, no, which is equal to, if you will substitute the fa and ga value 0, obviously we will get limit x tends to a, no, x tends to a, then fx minus 0 upon gx minus 0, and 0 if you will subtract, then what you will get? Limit x tends to a fx by gx. This is your proof. Okay, this completes the proof. No, this is your proof of the L'Hospital rule. L'Hospital rule proof is this. So after the getting the L'Hospital rule proof, let us have how to apply in the problem. How will you solve the problem? So to show it, let us one or two different kinds of problem we can take it. So I'm going to take the problem here. Questions for this. Questions. Evaluate. Okay, evaluate limit x tends to 0, 3x minus sine x upon x. This you are going to evaluate it. Let's have the solution for this. Solution, you are going to evaluate. So I will write the question again. Limit x tends to 0, 3x minus sine x upon x. If you will substitute now the 0 value here, no, obviously 3 into 0, 0, sine 0 means 0, 0 minus 0, numerator you got 0, no, and denominator x you will keep here, then you will get 0, 0 by 0 form. So you can apply the L'Hospital rule because it is indeterminate form. So L'Hospital rule says that limit x tends to 0, just do the x tends to 0. X tends to 0, do the derivative here of numerator separately. Obviously you will do derivative of 3x, then you will get 3 minus sin x derivative is your cos x upon 1. Then no need to write the x tends to 0, 1 no need to write in the numerator, you will get 3 minus cos x. No, and you don't have denominator, then no need to check the L'Hospital rule. No, so now substitute 3 minus cos 0, then what you got, 3 minus 1, which is equal to 2. This is your required answer for the L'Hospital rule. Okay, and similarly in the next question, let us talk about the next question. Evaluate limit x tends to 0 root under x plus 1 minus 1, then minus x by 2. No, in the numerator, and in denominator you have x square. This is your questions. So let's have a solution for this solution. So first I will write the question, rewrite the question again. Limit x tends to 0, you can write this x plus 1 to the power 1 by 2, no, minus 1, then minus x by 2 upon x square. If you will substitute now 0, what you will get, 0 plus 1, 0, 1 to the power something, then obviously 1 will be the 1 minus 1, 0, and this 0 by 2 means 0, means you got numerator 0, and by in denominator if you will substitute 0 of a square, then 0, so 0 by 0 form. You can apply the L'Hospital rule, which is because due to indeterminate form. So you can apply it, which is equal to limit x tends to 0. L'Hospital rule says that just do the derivative numerator 1. So if you do the derivative of this part, you should apply the power rule. So 1 by 2 x plus 1 to the power 1 by 2 minus 1, no, of this one. Then 1 derivative will be the minus 0, and minus x by 2 derivative is 1 by 2 by, then what you have here, 2x you will get. Just once you need to calculate one more time. Limit x tends to 0, and you will have here just 1 by 2, and then x plus 1 to the power minus 1 by 2 will be, you will get here minus, and then 1 by 2 upon 2x. One more time, let's have the derivative. No, why? Because if you will substitute the 0 plus 1, then 1 to the power something, then 1 into 1 by 2, then 1 by 2 minus 1 by 2, then you obviously will get 0 upon, if you will substitute here 2 into 0, then 0 by 0 form. So you can apply L'Hospital rule once again. So which is equal to limit x tends to 0, no, limit x tends to 0, then again you need to apply the power rule, 1 by 2 as it is, then minus 1 by 2 will product, and x plus 1 to the power minus 1 by 2 minus 1, no, and minus 1, and minus 1 by 2 derivative is constant, that is 0, then here 2, and x derivative is 1, 2 into 1. So now calculate once. So what you will get, which is equal to limit x tends to 0, you will get here minus 1 by 4 x plus 1 to the power minus 3 by 2 and by 2. Obviously you don't have 0, no, 0 by 0 form, so you can substitute this value, then you will get minus 1 by 4 and 0 plus 1 to the power minus 3 by 2 upon 2. So what you will get after calculation, minus 1 by 8 you will get. This is your required answer for the second problem. After this problem, I would like to go differently when there will be the single functions, no, in the numerator. In the numerator, how will you solve it then? Okay, if there will be the single functions, how will you solve it? I would like to go in that problem also. So for that I am writing the problem here. Questions. Evaluate that you have question, limit x tends to pi by 2 of means left hand derivative is minus. You should not means can be a confusion, be in confusion that minus means what. No, it is left hand derivative. Instead of that, you can write pi by 2. It doesn't matter to us. So you have the question. The question is x minus pi by 2, and then you have in the product tan x. This is your questions. Okay, then obviously you have the single function in the numerator only. So you need to apply the L'Hospital rule, you need to have numerator as well as denominator. No, so make it. So solution for this, rewrite the question once. Limit x tends to pi by 2 negative, means left hand limit, and then you have x minus pi by 2, and then in product tan x. So which is equal to limit. First let's have in the denominator one of the functions. So numerator keep as it is, x minus pi by 2 obviously, and then tan x is, you can say, 1 by cot x. So I will write directly here cot x. So you have numerator one of the function, denominator second function. So why you have written here cot x? Because tan x formula you have in trigonometry 1 by cot x. No, this is your formula for the tan x. Now which is equal to, obviously if you will keep the pi by 2 here, then instead of x, then pi by 2 minus pi by 2, then 0. No, and cot, if you will keep here pi by 2, what you will get? Cot pi by 2, then you will get 0, which is, this is 0 by 0 form. Okay, this is 0 by 0 form. So you can apply the L'Hospital rule. So L'Hospital rule, limit as it is, x tends to pi by 2 of negative left hand limit. Just do the derivative of this. X derivative is 1 minus pi by 2 derivative is 0. By cot x derivative you have cot x derivative minus cosec square x. Okay, you can have the formula of the derivative. So which is equal to limit x tends to pi by 2 of negative, then 1 minus 1 by cosec square x. No, you can write this limit x tends to pi by 2 of left hand limit, then you can write minus sine square x will be. No, just substitute it. The means x value you can substitute here. So minus as it is, sine pi by 2 of square, you can say. No, sine square means what? Angle. No, sine of square. Okay, then what you will have? Minus, then sine pi by 2 value is 1 of a square, which is equal to minus 1. This is your required answer for these questions. Okay, and nextly we will talk about when there will be the, in the limit, when there will be the power. Okay, when there will be the one of the functions should have the power, then how will you evaluate? So next questions for us is that so that I can write, so that evaluate, even you can say, so that limit x tends to 0 positive. Okay, right hand limit 1 plus x has power 1 by x. 1 by x is equal to e. You need to, if evaluate will be, then obviously e will not be given, your answer will be only e. Okay, so you need to show these questions has limiting value e. Okay, so for this let's come to the proof. So that is, so we can say proof. So question you have for that, so in case of power, when there will be the power in the functions to the functions, then suppose this function you can consider y. Let y is equal to 1 plus x, okay, to the power 1 by x. This you have considered. To remove this power to the power, take the log y, taking logarithm on both sides, taking log on both sides, taking log on both sides. Okay, what you will get? Log y is equal to log, then 1 plus x to the power 1 by x will be. By the log property, log y as it is, when there will be the power to the power in, and then log function will be there, then this power will come in the product form, then 1 by x, then log as it is 1 plus x will be. So what you have again? Log y is equal to log 1 plus x upon then x. You do have two functions, that is one of the numerator and then a denominator. Now you can take the limit on both sides. Taking limit x tends to 0 positive on both sides. Both sides you can take the limit. When you will take, what you will get on the left side, limit x approaches to 0 positive log y, which is equal to limit x approaches to 0 positive log 1 plus x upon x. If you will substitute now the 0 here, log 1 plus 0 means log 1 value is 0. 0 by 0 form you will get. No, you will get here 0 by 0 form. Okay. Obviously you have what? 0 by 0 form. Then you can apply L'Hospital rule here. So left side as it is, left side log, you can keep here log limit x approaches to 0 positive y, which is equal to limit x tends to 0 positive, then log 1 plus x derivative. Log derivative is 1 by and then that function 1 plus x upon then x derivative you have 1. So simplify once. Log limit x approaches to 0 positive of y, which is equal to limit x approaches to 0 positive. Obviously you have 1 after simplifying 1 by 1 plus x. So you don't have 0 by 0 form here, so you can further you cannot apply the logarithmic. Okay, further you cannot apply the L'Hospital rule. Substitute this 0 positive value instead of x. Then what you will get? Left side as it is, x tends to 0 positive, okay, y, which is equal to, if you will substitute, then 1 by 1 plus 0 you will get 1 plus 0, then 1. Obviously only 1 you will get. Then further if you will take log on the right side, then you will get log next right side, then e to the power 1 it will come in the power. So limit x approaches to 0 positive, y value you can substitute. 1 plus x to the power 1 by x is equal to e. Proved. When there will be the power to the power, one of the function has again power, then you can take you can suppose that function to the function as y. So one more you can question, let's have tried. Okay, let's try the next question so that we will be able to understand. So in case of evaluate, next question I'm going to write here, evaluate. Okay, evaluate limit. Question is your limit x tends to 0 and then cos x and you have cot square x. No, this is the questions. When function has next function, another function in the indices, then you know that you need to suppose it. So let y is equal to, you need to suppose this function cos x then to the power cot square x. So to remove this power to the power, no, so you should apply the log. You should taking log on the both sides. Take the log, taking log on both sides. We get what you will get. Obviously you will get what? Log y is equal to log, then on the right side you have cos x and to the power cot square x. By the property of log, it will come in the product. So log y left as it is, left side, so cot square x, and then you will have log and cos x. No, this you got. So you need to have the to make the numerator and denominator. So change this take in the denominator. So left side as it is, log y is equal to log cos x. No, and by obviously you will get 10 square x. Okay, so now take the limit x tends to 0 on the both side, taking limit x tends to 0 on both sides. We get what you will get. obviously you will get here limit, left side is limit x tends to 0 log y you have in the left side, no, and on the right side limit x tends to 0 log cos x upon tan square x. Okay, and you do on the left side you don't have indeterminate form, but the right side you have. If you will substitute 0 0, then cos 0 1, log 1 means 0, and by tan 0 0 means 0, 0 by 0 form you have on the right side. Okay, you can apply the L'Hospital rule on the right side. So or left side as it is, limit x tends to 0 log y equal to limit x tends to 0. Obviously log derivative is 1 by then cos x. You should have in the product form cos x derivative, then will be the minus sin x. Should I show here? I will show here in the, so that you will understand easily. To calculate log cos x derivative with respect to dx, what you will do, you need to have the chain rule first. D log cos x upon d cos x into d cos x upon dx, this you will have. Okay, and log derivative, when the next part function will be same, then you can say 1 by the derivative of log is 1 by cos x into derivative of cos x with respect to x is minus sin x. So you have here minus sin x upon, in the denominator what you will get, then derivative you need to calculate tan square x with respect to what, dx. No, first you need to have the chain rule d tan square x upon d tan x, and then into d tan x by dx, this you will have. No, so you should apply here in the first part, you need to apply the power rule, that you will have 2 tan x only in the first part, and then tan x derivative you will have sec square x, tan x derivative you will have sec square x. Next part here, this part you will have sec square x, and this part you have n minus 1. Okay, 2 tan 2 minus 1 x. Okay, so 2 tan x only you will get. So after solving, what you will get on the left side, obviously you will have left side as it is, limit x approaches to 0 log y equal to limit x tends to 0 sin x by cos x, obviously you will get minus tan x upon 2 tan x, and then sec square x you will get. Tan x and tan x will be the removed. Okay, cancel will be x tends to 0 log y equal to, then you will have here you can substitute the value. If you will substitute, what you will get, minus 1 by 2 only you will get. No, because sec 0 is 1, so 1 into 2 means 2 only, so in the numerator you have 1. So or you can have log in the outside, limit x tends to 0 y as inside the bracket equal to minus 1 by 2. If you will take log on the another side, then therefore you will get limit x tends to 0 y equal to e to the power minus 1 by 2. Now you can substitute what you have assumed for the y. Obviously you don't have in the question y, eliminate the y. To eliminate, you should substitute the y value as instead of y. So therefore limit x tends to 0 cos x then cot square x is equal to e to the power minus 1 by 2. This is your required answers for these questions. Okay, now nextly I would like to go in the next questions. Next question you have, you can do question for you. You can simplify the limit x tends to 0 1 by x square 2 has power 10x. You can do in same way. The answer of these questions will be your, the answer of this question as it is. Okay, it will be same. Answer of this question will be your 1. You can simplify it. I would like to go in the next questions when there will be the different numerator. Okay, means separated function will be there, then what you will do for that functions. So for evaluate limit x tends to 1, then you have 1 by x square minus 1 minus 2 by x4 minus 1. This is your questions. How will you simplify of this question, or how will you evaluate it? Okay, obviously you have two fractions are there, so make the fractions single fractions, because to apply the L'Hospital rule, the denominators or numerator should have single function and denominator should have single function, but here are two functions is subtracted, so make it single function, single type of numerator and denominator. So for that I will write the question once more. Limit x tends to 1, then you can simplify. Obviously if you simplify, then you will have the LCM x square minus 1, then x square plus 1, no, and 1 will be multiplied with x square plus 1 and minus 2 as it is. Okay, so which is equal to limit x tends to 1, then after simplifying what you will get, x square minus 1 you will get in the numerator, and denominator x4 minus 1 you will get in the denominator. So if you will substitute now 1, you will get what, 0 by 0 form you will get, which is indeterminate form. No, you can now apply the L'Hospital rule, which is equal to limit x tends to 1. So L'Hospital rule says that just do the derivative numerator and denominator separately. Obviously if you will do the numerator derivative, then you will get 2x only, and denominator derivative then 4x you will get. So which is equal to limit x tends to 1, then you will get what, x will be cancelled, 2 will be cancelled, 1 by 2x square you will get. If you will substitute the x value, then 1 by 2, 1 of a square, which is equal to 1 by 2. This is your required answer. This is the next type of problem. When the two fractions will be there, you need to make it single fractions, then you should have simplification of that question, that problem. Okay, and similarly I would like to go the last problem of this. So problem is your questions. Determine, question says that determine the values of ABC. Okay, so that you should have the value of ABC, so that the limit x tends to 0, a plus b cos x is multiplied with x minus c sin x by x to the power 5 is equal to 1. Means limit exists and limiting value is 1. Okay, your question is this one. No, question you do have this one. So just you need to have what, you need to find the value of a, b and c. Okay, so solution for this, I will write the question first. Left side we have limit x tends to 0, we can write, we have limit x tends to 0, a plus b cos x is product with x minus c sin x and by x to the power 5. This is your questions. If you will substitute now 0, what you will get? Obviously 0 is multiplied with this term, then 0, and sin 0 means 0, 0 minus 0 is 0, so numerator you do have 0, and denominator if you will substitute the instead of x 0 to the power 5, then you will get 0 by 0 4. So you can apply the L'Hospital rule. So L'Hospital rule says that what means, do the derivative of numerator and denominator. So for that I would like to do the product form here, because two functions are in the product. So here you can keep x as it is, thus do the derivative of this inside one. A derivative is 0 and plus, and b cos x derivative is minus sin x. Okay, and then plus. Now nextly you need to have this as it is, a plus b cos x as it is, and x derivative you have 1 minus the derivative of this one is c cos x upon, and then 5x4 you will get here, no, 5x4. After this, so once simplify first, x tends to 0, Then if you will multiply with this x, then obviously minus x b is also there, b minus bx sin x you will get, and in here plus a plus b cos x minus c cos x upon then 5x4 you will have. If you will substitute now 0, what you will get? 0 into something, then 0, then you will have here a as it is. If you will substitute the 0 a as it is, cos 0 means 1 plus b you will get, cos 0 means 1 means c you will minus c by, and if you will substitute in the 0, then obviously you will have 0 form, a plus b minus c equal to c by 0 form. No, but what we know, but this is not indeterminate form, but you know that as limit exists, because limit value you have, as limit exists, so we must have, for the existence we must have, okay, we must have that a plus b minus c must be 0. No, then only you will have you will apply the L'Hospital rule, then only limit will exist. Okay, so this, and obviously if you will get this 0, then 0 by 0 form you got. Now once again you can apply the L'Hospital rule, so which is equal to limit x tends to 0 as it is, then minus b as it is. You can keep the product here, product rule you can apply here in this function, x as it is dot sin x derivative is cos x, and plus sin x as it is, and x derivative you will have 1, and plus a derivative you will get 0, and you will get here cos x derivative is minus sin x, then obviously you will get minus b sin x, and here what you will get, cos x derivative is minus sin x, so plus c sin x upon, you will have here 20x cube. No, this you got. After then this limit, once simplify this, x tends to 0, multiply with b, then minus b x cos x minus b sin x, and minus b sin x you will have here, plus c sin x upon 20x cube. X you haven't here in this term, so after then you can add it. So limit x tends to 0, minus b x cos x minus 2b sin x and plus c sin x upon 20x cube. If you will substitute here x tends to 0, what you will get? Obviously you will get 0 this term, and this term you will get 0, and this term you will get 0. 0 by 0 form you will get. No, 0 by 0 form. That means you need to know what you need to do. Is it okay or not? I think any problem? I will see this, you continue it. Okay, thank you this much for today.